What are we required to prove? We are required to prove that this angle is twice that one. We are required to prove that angle AOB is twice angle ACB. That is 2 times ACB. Right now we are going to what? To construct. In every theorem we need to construct, so we are going to do the construction. Where are we going to construct? We are going to join CO or OC and produce, meaning that we're going to extend that line a little bit. So we're going to do like this. Remember, when you're constructing, you should draw dotted line. CO and produce. So allow me here to say this is O1 and this is O2. Let me do it like this. This is O1 and this is O2. This is C1 and this is C2. The reason for me to do that with I don't want us to entangle ourselves here. I want us to flow. I'm trying to make things easier for ourselves. Right now we are free to prove. Have a look here. We've got 2 triangles. We've got ACO, this part of triangle. This is a triangle. We've got BCO. That is another triangle, right? So we need to prove it in those 2 triangles here, but we need to take each triangle at a time. Right? We are going to take triangle A. We can say triangle AOC. Okay, so in triangle AOC, we need to find statements and reasons. The first statement here, you can see that this triangle has got an exterior angle, right? It has got an exterior angle. So I hope you are familiar with this theorem, with this statement that an exterior of a triangle is equals to sum of the opposite interior angles. Okay? So we are going to say angle O1 is equals to angle C1 plus angle A. What is the reason? You can say sum of, you can say exterior angle of a triangle. If you have written like this, we give you full marks, right? You will get full marks. Right? But if you can have a look here, this line is from the center to the circumference. And this line again is from the center to the circumference. So it means those two lines are equal, right? Why? This is a radius and that is a radius. So if those two lines are equal, it means the whole triangle here is what? An isosceles triangle. Then what do you know about isosceles triangle? Their base angles are equal. It means angle C1 is equals to angle A. What is the reason? You can say isosceles triangle. Isosceles triangle. We will give you full marks. We know what you mean. We know the meaning of that, right? So, okay, going further here, we said angle O1 is equals to angle C1 plus A1. But here, have a look here. If you can take that statement here, O1 is equals to C1 plus. We said here C1 is equals to A. Can you see? A here is equivalent to C1. So it means that when we come across angle A, we should replace it with what? C1. Right? And now we've got angle O1 is equals to. These two are the same. Then we should add them. This is the same as x plus x. Your answer will be 2x. Okay? Your answer will be 2x. The same applies here. For C1 plus C1, we are going to get what? 2C1. Right? So we can press pause for now here. Let's take the other triangle that side. The other triangle this side. In triangle. We're proving in triangle BOC. BOC. In triangle BOC, the same applies here. We have got what? O2 as an exterior angle of the whole triangle here. So O2, angle O2 is equals to angle C2 plus B. What is the reason? The reason is the same. Exterior angle of a triangle. Right? But C2 is equals to what? Since we know that this line is equals to that line on this triangle. Both of them are what? Radii. So they are equal, meaning this is an isosceles triangle. So if it's an isosceles triangle, it means their base angles are equal. So it means C2 is equals to angle B. Okay? Right, going to this statement, we said O2 is equals to C2 plus. Right. Here we said C2 equals to B. Here we are, we're coming across B2. So we are allowed to kick that B2 and replace it with C2. Now, this is addition. O2 is equals to 2C2. Okay? So we can add the 2 here. O1 equals to C1, O2 equals to 2C2. So we can say O1 plus O2 is equals to 2C1 plus 2C2. Right? So now, O1 plus O2 is equals to, let's take out a common factor here, which is 2. Then we'll remain with C1 plus C2. Right? So let's have a look. What is C1 and C2 from our diagram? I mean O1 and O2. O1 and O2 is this angle here. Is this angle. So we are allowed to say, instead of O1 and O2, we are allowed to say AOB. This is the same thing. Can you see that? AOB. It's the same angle.
AOB is equal to AB.
OB.
And it can be a name.
Right? This is equals to 2. Then now what is C1 and C2? Let's check again from our drawing. C1 and C2. Then C1 and C2 is this triangle. So let's get rid of them and say A. Yeah, this is AOB. It's this angle. Now, it's equals to 2 C1 plus C2. C1 plus C2 is this angle. Let us get rid of C1 and C2 and say what? ACB. ACB. It's the same thing. It's the same thing. Have a look here. We were required to prove that AOB is equal to 2ACB. AOB is equal to 2ACB. AOB is equal to 2ACB. We are done. Our job is done. Then now we are left with what? Theorem 3. This is how you do Theorem 2. If you do it like this, you will get full marks. We will give you full marks and you will be able to get what? A distinction. Thank you very much.